Hi there, welcome to the first review of this channel, on this channel, and this is a review of this book, The Physics of Semiconductor Devices, from Oxford Physics series. So it's about microelectronics. Now this is actually a library copy, as you can see here by this sticker. I borrowed this because in the first semester of an electrical engineering degree, we are studying at the University of Stuttgart in Germany, and we have to take microelectronics with the name Microelektronik 1, meaning microelectronics 1, in German, of course, and it covers semiconductor materials and semiconductor devices just a little bit. It's spread over 2 semesters, like 1 and 2, and I just wanted to borrow this for a little bit. Now it's only the beginning of November, so not even 4 weeks have passed, I think, yeah, since the semester began. But still, I wanted to borrow a short, quick book just so I can get my feet wet. And it's been great. I will compare it to some other books that I know. But I have looked at the content. I've seen some of the problems inside. Let me just go to a random page, like more towards the beginning. What's this density of states? Okay, so the book is in English, even though my course is in German, which isn't perfect, but it's not bad either. Like, I still understand, and our professor actually recommended us read, like, to the entire class. Recommended us learn everything in English, since most of the research done and most of the discoveries that are being done are made in English and need to be translated later on. Now, what chapter is this? Electrons in solids. Let me see if I find any problems here. At the end of every chapter, yeah, I have here, at the end of every chapter, you have a list of problems that aren't really difficult. Some of them are more interesting than other ones. Now, I think this is chapter 2. No, that was chapter 1. Okay, interesting. And yeah, the chapters are also structured in like small sections, as you can see here, with different themes. Okay, these are sub sections. So these are the sections I mentioned. So the general chapter is electrons in solids. The section is diffusion of carriers, and it has it has subsections or subsections, whatever it is. It has a lot of like diagrams and things, which is plenty nice. It has a lot of graphs as well, which is really useful for understanding better. Now, I actually borrowed this book not to solve all the problems, not to cover it like really in depth, but more just to read it like a supplementary lecture thing, just because I wanted to understand the material before we get to it during the lecture. Now, the class being in German and me being like an international student, I don't. I mean, I know German. We did take the C1 certificate in German. It was actually required to enroll in the university, and have been able to speak C1 German for like a year now. But still, some professors talk with more of a local dialect, or also with an accent. Now, here we have the table of contents. So, as we saw earlier, electrons in solids. I found this chapter to be okay. It was an okay introduction, not great for total beginners, but it was okay. Bulk effects, which was a little bit better. PN junctions, which it was amazing. I love this chapter. It's the best exposition of PN junctions I have read yet, but there are some books that I'm looking forward to that might have better exposition than this. The other book that I read PN junctions on. Wait, there were 2 books were in German. I'm gonna look over them a little bit later. But yeah, PN junctions, then junction and junction transistors and thyristors. This was also great, not as good as PN junctions. Also, I forgot to mention it here. So underneath the chapter title, it has every section of that chapter, and the section that I found best explained in the book overall was breakdown in PN junctions, and then solar cells. Like, I found that actually interesting. Yeah, so chapter 5 is surfaces and interfaces, and chapter 6 integrated circuits. The book has like 188 pages in total, and it also has some appendices later on, like appendix, answers to selected problems, bibliography, and so on. It's also from the Oxford Physics series. It's the 4th edition, written by Fraser, I think. Let me see. Oh yeah, here you can see like the University Library of Feigen, which is where my campus is situated. Yeah, 1986, a bit old, yeah. But from what I know, things haven't changed that much. I also asked our professor about this book in particular, like after the lecture, and he said, "Yeah, I've read it. It's okay if you're just planning to read through it just to understand the material better, but you shouldn't like use it for actual learning." I didn't find it great just because it was too short and you need to jump a little bit from section to section. Like there's no transitioning into each topic, which wasn't great. Now, who would I recommend this book to? Actually, the students that are like me, like who just want to see the concepts a little bit to get to know them beforehand, before the lecture gets there, because you can only teach so much in a 90-minute lecture. Now, some other books. This is another book that our professor recommended to us, and it's actually my next read after this one. This is Grundlagen der Halbleiterelektronik, which would translate to, it's in German, but it would translate to fundamentals of semiconductor electronics. It's by Robert Müller, and it's published by Springer Verlag, which is Springer, which became international, but it's actually German. This is the first volume in a long series. Like I noticed tens of volumes. This is the receipt I got for borrowing this. I have to turn it, like I have to give it back on the 29th of November. Okay, let's see. It has some like some formulas, some things like that. Mathematics, some constants, some values, things like that. Let's look over the table of contents. So yeah, it has like, what's this? Introduction, then the structure of the semiconductors, the electric properties of the semiconductor, the band model, which is great. What next? It's covering like different things of the different properties and different aspects of the semiconductors. Focus is way more on semiconductor materials. Like you can see here, like we got the PN junctions at page 129, and in the other book, like this one, it was on page 60 or something like that, so way earlier. This is supposed to contain the entirety of the Physics of Semiconductor Devices, while this is just volume 1. But both of these books are tiny, like under 200 pages long. Now the next lecture after that, and this is not actually a lecture, this will be no lecture, reading. I meant to say reading. Like the next reading after that will be the Sedra and Smith microelectronic circuits. This is also borrowed from the library, as you can see here. This is the well-known textbook. Like this is the reference grade 1. It's 1600 pages long, something like that, and it covers everything the other two books cover, but also transitions very well between them. It's way more in depth, has way more, let's just go to a random page. It has way more drawings, it has schematics, it has everything, and I'm hoping to get here soon, because the exam that we're gonna take is gonna be somewhere in, it's gonna be actually 2 years, because we're going to take the exam on the end of the second semester. So I have like a couple of months, like 8 months to read all of these. But I also plan on getting some other books in the future, some other good books also in German, because both of these, like the Oxford Physics series and the Sedgwick and Smith, are in English just because I couldn't find them in German in our library. And this one was recommended by our professor because it's in German and we should read at least one book in German. But yeah, this has been the review, this has been the video. Hope you found it great, and see you in the next video.